universal asynchronous receiver transmitter mode. So of course we have the polling mode and the data type conversion. We will see now. So you can configure the pin in terms of your transmitter or your receiver in polling mode, and that is used to convert integer number or and real number into string for your transmission. So remember, UART, this is a serial data transmission. So whatever the data we get in the 7th layer, we need to convert that data into serial data, parallel to serial data conversion. Okay, so we will see here, this is the UART data frame. In the communication networks, we had seen different protocols. Each protocol has its own data frame format. So this UART is a serial data communication. So this is also using certain data format or data frame template. So here you have the start bit and here you have the stop bit. This is to indicate the start and stop, the start and end of the data frame. So here we have the data bits. This is the actual data bits, bit 0, bit 1, bit 2, and so on, bit 7. So 8 bits. Always LSB first, MSB is the last, least significant bit and most significant bit. Okay, and we have the parity bit, that is the P. This is for error checking. So we have studied about different types of error checking in the last semester. So for example, CRC, remember the CRC we studied in detail. You have even solved some problem, cyclic redundancy check. So we add some kind of error detection code. So then only when the data received by the receiver, we can check if the original data got modified or not because of the data transfer, because it needs to go through several routers, right? That is, okay, when we talk about this UART data frame, maybe it's not going through several network, but it's just directly you are connecting the cable, USB cable, and transferring from microcontroller to your PC. But anyway, logic is the same. So we have to have the parity check and we have the data bits, and we must need start bit and stop bit to differentiate from frame 1 to frame 2 between different frames. Otherwise, if you send these bits continuously, then you don't know where the frame 1 starts, where the frame 1 ends. So this is the start and this is the end, and then immediately the receiver will know, okay, I finished with the frame 1 and then I am receiving the next frame, that is the frame 2. Okay, these are the theory behind the communication networks. So UART is mainly used as an interface between microcontroller and PC, or microcontroller and other modules to transfer the data. It's asynchronous. TX line means there is a transmitter line. It's used for transmitting the data, and RX line is to receive the data. So in any microcontroller, when you set up a transmitter, you must also set up the receiver. For example, this is the pin number 6, let's say port A, PA5, pin number 5, and this is the pin number 6 in port A. So if I set up this pin number 5 as a transmitter, then I must need to set up another pin as a receiver, because I am transmitting this data to maybe my PC from the microcontroller. This is the microcontroller and this is my PC. So my PC is connected to this. So in my PC also I have the transmitter and receiver, because this is a bidirectional communication. So you are sending some data. This transmitter is connected to the receiver of this microcontroller. Let's make it a little more clear. This is the microcontroller and this is the PC. So I have I can change the color. I have the transmitter. I have the receiver pin. and here I have the transmitter, and here I have the receiver pin. So let me take another color. So this transmitter is connected to the receiver of this microcontroller, and this transmitter is connected to the receiver of this PC. So when I send the data, then the data is traveling and reaching this receiver pin of the microcontroller. Then the microcontroller will process the data or whatever. Similarly, I send back some result to the PC. Then this data is transferred to through this path. This is the data transfer path. Okay, so everything is and how this data frame is defined. Everything is mentioned in this communication protocol. So we can use a different protocols. This is the communication protocol. It can be any protocol that will define all the rules how the data should be represented in the data frame. Okay, so now UART is a circuit that converts parallel data into serial data to transmit the receiver side. So I am transmitting the data as a receiver transmitter to the receiver. So this part is the UART communication. UART communication, and you have the UART interface here. Maybe I change the color. UART interface. So here I have the UART interface, and here I have the UART interface, and here I have the UART communication. So what the UART interface is doing, so whatever the data we want to transmit, we need to convert the data into serial data. So I have maybe number 1, let's say. So if I represent that in the 0001, 4 bits, or if I want to represent in 8 bits, then I can say 00000001, right? So this data, so this data is coming to this transmitter pin. So you cannot transfer all these data in parallel. So it must be transmitted in serial. So for example, the 1 will be transmitted, and then the 0 will be followed by this 1, then 0 will be transmitted afterwards, like here. Bit 7 will be transmitted, and then the bit 6, and then the bit 5, and then the bit 4. This is the transmission cable. So the UART will convert the data like this, and then it will send. Okay, so parallel data into serial data, and serial data into parallel data. So I convert whatever the data like this. I send bit by bit in the cable, and then the receiver side, the receiver should rebuild these bits into a frame. So then this data will be constructed into a single. Here we are sending number 1, right? Decimal number 1. So this data needs to be constructed 000001. Of course, I'm sending so many number of data frames. So all these data frames will be rebuilt into a data. Then you will have in the PC, you will see in the user interface the data. So if you have the parallel to serial converter, in the transmitter side, in the receiver side, you must need serial to parallel converter. This is what mentioned here. So most commonly used data bits are 8 bits. Okay, the LSB is bit 0 and MSB is bit 7. Start bit is always 0 and stop bit is always 1. So remember this, we have a start bit and stop bit. Start bit is always 0. You can see here the low level, and then this signal went up from 0 to 1 transition. So stop bit is always 1. It's indicating the frame is finished. Okay, and then stop bit can receive either 1 or 1.5 or 2 bits. Okay, the parity bit, that is the to know about add parity or even parity. So the parity bit will indicate, for example, now I am sending Let us say like a 0 0 0 0 0 0 0 1. So how many number of ones I have here? So I have only odd number of 1. So this will be set here the parity bit as a 1. So when I receive in the receiver side, then I check this parity bit. So then if I see this 1 here, then I will know there is odd number of ones. So now I have here 1 instead of here 0, I have another 1 here. So now I have 2 ones. So then this is the even parity. So we set up 0 here. So the receiver, when it receives this frame, this data frame, then it will see number 0. Then where is this cursor? Then here the receiver side, it will check the parity bit. Then if it's 0, then it will know. So the number of ones is even number. So this is 2 1 2 2 ones. So then it will check in the receiver side how many number of ones. But there is a possibility during the data transmission, this bit can be flipped into 1. Then you will have the wrong data. So this parity bit based error detection technique is not a very efficient technique. That is why we use some other techniques, CRC and so on. Okay, so we send the data frame like this through UART mode. So baud rate can be either 9600 or 19200 or 11,005. Sorry, this is 115200 bits per second. So you can set up the baud rate. We had seen baud rate means what, and we had seen the definition in the last semester, I think. I'm sure last semester we had seen the detail of that. Okay, example your data frame. So this is the data frame. We know that LSB, MSB, and we have the start bit 0 and stop bit 1. And this is the data we are sending. So for example, now we are sending the ASCII character A in bit level from transmitter to the receiver. Okay, so here you can represent the data frame in 8N1. So what it means, so we always know this start bit is 0 and stop bit is 1. So there is no problem. If I mention 8N1, it indicates 8 is indicating the total number of data bits. It is the 8 bits. And the N is indicating there is no parity. I don't set any parity. If I set the even parity, it can be E. If I set the odd parity, it can be O. And this 1 is indicating the stop bit. So you can represent the data like this. The data frame, simply you can say this is an 8N1. So if I ask you like what it indicates, then you should tell this is the data bits, number of data bits, and this is the parity, and this is the stop bit. That is for the exam. Okay, so your data frame. So you can represent the data bits in terms of signals. We had seen different encoding techniques. How can we represent the data in terms of signals? Encoding techniques, right? So here, so each encoding technique, we have different encoding techniques. So each encoding technique is using different logic. So for example, the TTL logic, this is a transistor logic. So here we are representing plus 5 volt or plus 3.3 volt. You see here, plus 5 or plus 3.3 is logic 1, and 0 volt is logic 0. That is represented in this TTL logic. And we have another logic called RS232. The most commonly used serial data communication is RS232. So in this RS232, we represent the same data bits, but using a different logic. So here you can see plus 3 volt to plus 15 volt and minus 3 volt to minus 15 volt. So minus 3 volt to minus 15 volt can be represented as a logic 1, and plus 3 volt to plus 15 volt, that can be represented as a logic 0. So you can decide what kind of encoding technique you want to use to convert this digital data into signal, and each encoding technique will use a different logic. Maybe in another encoding technique there will be another logic. So this is for RS-232. It's using this technique or this logic. TTL is using this logic. So we use both, but nowadays we are not really using much into our TTL. We are using this RS-232 for the data communication. Okay, so because mainly nowadays our PCs don't have the VGA port. In the previous years, maybe even just few years ago, we have always VGA port in our laptop for the data communication. But nowadays we only have the HDMI port and USB port to connect to, for example, to your monitor, USB port. So you have these kind of ports. Why do we have these ports? Because whenever the data comes from the external world to your PC, for example, this is a hard disk, you have the external hard disk. You want to transfer the data to your PC, you are using this port. And if you want to transfer some data from your PC to external hard disk, you are using this port. So this port have the interface. So we are talking about receiver, transmitter. So we have the pins, and then the pins, each microcontroller inside your PC has the transmitter and receiver pins, and it's used to transmit the data, and it can receive the data from the hard disk or any external device. So this is the serial data communication. Of course, this is just one small example. So the microcontroller or the PC, we also have the transmitter receiver. This is the part of the PC. Let us say PC is using the TTL logic or TTL to USB logic or TTL to RS-232 logic. We are transmitting the data from microcontroller to the PC or the other way. And the serial monitor, for example, in your assignment, you are going to use your microcontroller. You will sense the data from the temperature sensor, and the temperature sensor data will communicate with your STM32 microboard or microcontroller PCB, and then you are receiving the temperature sensor data back to your computer or your laptop, and you are seeing in the serial monitor. So you have to have the serial terminal program. You must install that in your PC. Serial terminal program. What is this serial terminal program? This can always work with these channels, communication port, and whatever the data you receive from the sensor, you can see that in the data. You can see that in the monitor. This is the user interface. There are so many serial terminal programs available. You can use PUTTY, PUTTY. You have to configure this. You have to install and configure. So you can use PUTTY or you can use Hercules. So these are called serial terminal program or serial monitor. So this will help you to read the data from your sensor through this microcontroller board, and then you can you can see the data in the numbers in your monitor or in your PC. Okay, so this is the example UART connection. So you will experience this by yourself when you do the assignment number 2. The interrupt mode example 1. So here we have the main program, and then we have to use this hall library variable hall underscore UART underscore transmit underscore IT, this parenthesis, and you can transmit the data to your serial terminal program, hello world. You have to edit your C code, of course, and you can transmit this data with a 1 second delay. So here you can see here the sample code consists of a main program. This is the main program, and UART ISR module. This is the UART interrupt service routine. In the main program, we have the hello world message that will be sent every 1 second to the PC using this command. So this is not a command, this is a command. So by using this command, you are transmitting this data to your PC. but of course via this all underscore UART function. And whenever, of course, whenever this interrupt occurs, then the CPU will take this interrupt and it will process based on the priority, because this is also an interrupt. When something in some incoming data comes to the UART register, then what will happen? UART interrupt will occur in the microcontroller. Then through this function, then this data will be given to this RX buffer. So whenever the data, maybe if it comes from the sensor, let us say, it will first come to interrupt will come and reach this microcontroller, and then the microcontroller will start to process this data. We are sending the data based on this function, and the receiver side we have the receive function. This is receive underscore IT within parenthesis, and we receive this data, and this received data will be sent to this RX buffer. So this is just one example how we can transmit the data from the main program using this transmit function, and the receiver side we can receive it by using this receive function in this, and you can see in the serial monitor or serial terminal program. So we are moving a character from UART DR to RX FIFO buffer. So when data reaches this data register, UART data register, the UART interrupt occurs, then it enables the data transfer to the RX FIFO buffer. That's we had seen just before. And similarly, this example 2, what we are talking about is we have the main program. You can add a switch. You can add a switch. When you press this switch, what will happen? You are giving the external interrupt to the microcontroller. So main program will take all characters from FIFO buffer. That is the first in first out buffer. This is the buffer. Then until you see or until the program meets the new line. So here you can see here new line. So in here, this is the 1, 2, 3, 4, 8-bit data. So in this 8-bit data, I put a new line character in some registers, in some flip-flops. So what happens here? So here the FIFO buffer. So let's say here main program will take all characters from the FIFO buffer until new line character and transmit the data including new line to the PC. Yes, then you can also set up different examples. You can also use some kind of functions like DMA function. There is a direct memory access. You can also transmit and receive the data without using the CPU resource. You can perform the data transfer. So for example, here now I have you can see here the sine wave. You can implement this sine wave in your serial monitor just by using this command sine or saw. I think if you read this one, you can understand. So command in UART DMA mode. So it will create this waveform. So what is happening here is everything in terms of numbers, zeros and ones. So the program will reconstruct the numbers and it will build this sine wave. You can also build some non-sinusoidal waves. You can read this by yourself in this UART. How can we use this UART in microcontroller? So you have to always set up the enable this one. So here, for example, in this example, I used the DMA1 in channel 6 and 7. It got enabled, and also I used the UART mode. So UART global mode I enabled. If you don't enable this, then the UART cannot transmit the data.